Hello, and welcome to Beyond Retrieval, adding a reasoning layer to RAG with Neo4j. We're having presenting today Ashok Vishwakarma. Sorry. Over to you.
Hey everyone, where I can share my screen. I can see camera. Okay, I can see that I can add my screen here. Let it come. Yeah. Also, let me hide this quickly. Yeah. So hey everyone, I'm Ashok Vishwakarma. I am presenting a case study rather than a session over here, which is called Beyond Retrieval. So this is a little about me. I run a company called Impulsive Web and I work as a CTO over there. I have been in technology almost 2 decades now, and I happens to be a Google developer expert for Web and AI, and also a Microsoft most valuable professional for AI and Neo4j Ninja as well. And today, this talk, what I'm trying to do is that we have built a couple of RAG application for multiple customers. This is one of our case study which we had done for a real estate company, and how we have leveraged Neo4j to add a reasoning layer into their whole RAG stack. So, so first thing I wanted to tell you that why I thought that it would be a good idea to present, right? So as we as we have been seen in various application, RAG stops just at retrieval, right? You can find chunks from a specific vector database, or maybe any specific database for that matter, and it works on more of a semantic match rather than getting into relationships and edges and other specific aspects around that. But when we build solution for a business, semantic match does work, does do the job for a very high level queries. But when we but as soon as those queries become more complicated, more logical, semantic match does not help that much, and it requires some form of reasoning. What we observe that when you add a graph, that's where you can have multi-hop queries, you can have dependency mapping, and that's what we think that you can enable for your AI to have a reasoning capability, or you can also call it that you can make your AI think to actually some extent. And it's also because your node and edges gives you the answers in a ground way fashion, so it reduces the hallucination of the LLM you're using. And at the end of the day, we are not just trying to answer a question, right? We are also trying to give much more information around that answer, which you can also call an insight, so that it can help user or clients much better. And as we have been doing this for multiple clients, and it's working. So yeah, it's proven to some extent with the real world case studies. So what was the case study in general? So we had a real estate data which was accumulated around 15 years, and we wanted to have a search logic built on top of it. But the problem was that when someone had a question, no one knows exactly where the answer lived, right? It's a very basic problem. But when we build our first level of solution that was completely based on retrieval and RAG, it was just giving the answers which was asked, but it's not giving any insights or any other lookups or any other relationships around that. The core challenge which we had in the beginning was that we had a very unstructured data. Like there is no way we can have shapes and all those specific things. There was no way within that vector database we can have multi-hop reasoning, or we can have any way of chaining where we can chain one facts to another and go from one edge to another. And there was no possibility to link those blocks to get to the root cause. So there was no sufficient information available by which we can tell, okay, this is happening because of these specific reasons. So what we thought, okay, why not leverage Neo4j and build all these individual entities into nodes and relationships, so that with the semantic match from the database itself, we can also refine that with lots of insights coming from Neo4j with the data. So we used retrieval for context, but then we also have some sort of reasoning to uncover patterns and relationship on top of it. This is the simple process which we had. Like we have stored all those unstructured data somewhere. We have turned them into chunks, and we have also extracted metadata and other specific information around that. We have used tools like Vertex AI and Gemma for our LLM and AI deployments, and we also had Neo4j to our relationships and graph basically layer. In terms of core architecture, we had a data layer, and we had a retrieval layer, and then we have a reasoning layer, and then we had a generation layer. In this session, what we are going to explore is the reasoning layer, because all of those are pretty much exactly as it is, which we can have in any RAG based application. So this is the new implementation on top of the ROG. So we'll be talking about this specific layers from this architecture only. So what we were doing over there is that first we were just chunking the data and having some metadata coming out of it, so that we can have information. Like suppose there is a PDF which we are trying to do multiple chunks, and then based on those chunks we are also extracting information that what are the entities from that particular PDF we can get. Like if you look at this example, let's talk about the project, where the location was, what the year was, what is the document is all about. And using this information, we are also using some of those internal intricacies using core NLP. And depending on what the context and text we have in that particular PDF, we are getting that information labeled using simple NLP methods, which can identify projects, vendor dates, and all those other facts which we can relate directly to a node. And then using that, we're just simply uh, creating those nodes into our specific database. And we are also doing some form of clustering based on the properties and attributes which we have in various entity and node types. And we are also having some sort of traversing, which enables multi-hopping with one nodes to another, with with the relationships and and the tags which we have already created and mapped. This was the process which enables us to do a hybrid retrieval, not just the vector, but we also have a chaining which we can get into the graphs. So if we talk about a normal retrieval where we have a simple question that, okay, let's talk about who handled HVAC in Riyadh Mall, for us, very simple question. When we get into the normal retrieval, the simple answer would be that, okay, this is the company who actually handled that particular project, and that's it. This was the answer before we have implemented the reasoning layer. But when we have our graph and hybrid retrieval in place, if we ask the same question, we're not just getting the answer, but you're also getting some additional information. That is there any delay? What if there is a delay? What other delays they have? And this gives you a conclusion that so when you ask a question, there is a motive behind that question, right? If somebody asks your name, that they want to know you. If somebody asks which college you went to, maybe they want to know a little bit more about the college. So understanding that region behind this specific question, and then answer that question keeping the context intact so that user can take an action. This is what we were able to implement and achieve using this hybrid retrieval method. So in in the traditional fashion, retrievals gets you the what, right? I mean, but when we have reasoning added, it gives you how, why, and who else. So it's expand the information in multiple direction, and it also gives you more insights and more information to act upon, not just the answer you're looking for. Uh, Here is a specific table which gives you a general use case where and when to use graphs, and when not to use graphs. So if you have a simple criteria where you want to just find similar meaning stuff, you really don't need graphs over there. But if you want to go on a relationship side where you want to explicit and implicit relationships available to you within your answer so that you can form better answers, then I think the graph would be much more suitable. Similarly, when you have semantic similarity versus multi-hop logic, you just want to deal with chunk text plus metadata rather than nodes versus edges, right? All those specific aspects around that. Your query style is natural with some sort of filters, but you don't want pattern traversal or other specific advanced mechanism to reach to a specific answer. Or simply like when you have a particular answer which does not have any specific logic, but you need a structure and you need a logic by which you can explain your answer, then actually graph suits much better. So what we end up having a particular knowledge base. So we have transformed that 15 years of scattered documents into searchable, and not just into a searchable interface, but also an a smart assistant, which end up having cut down the response time. Uh, the key outcome which we had is that we have reduced the search to answer time. It was days, weeks, depending on what we had, and earlier it was hours, because once we just answer the question, now they're gonna look for insights in other places, and they have follow up questions which are normal retrieval would not able to physically answer. Uh, we had these internal support questions coming from multiple departments, and we have automated those. 70% of them we have automated those through this particular approach and uses grounded response. We have also started seeing a spike of reuse of those specific documents which was sitting in silos somewhere in their ecosystem. And we also preserve the institution knowledge, like what they have done for last 15 years. They needed to use that in their next and upcoming project. So using all these specific solutions, we have preserved and retained the information they have already actually built upon. And because we were able to give the verifiable grounded context with a very specific answer, we have built the user trust to use our tool. I mean, if you no matter how good your tool is, if people are not using it, it doesn't make any sense. So the idea was that give them a reason to uh, kind of build trust from day one so that they can verify whatever the AI is answering to them. So it doesn't feel like that we are generating answers from thin air, but we are finding information from a knowledge base and then giving that information directly to the user. So at the end of the day, what we did is that like 15 years of whole chaos, and we built a smart system so that they don't have to do any control plus F to actually get to that. And I think that's all from in this talk. I mean, if you have anybody have any questions, I'll be happy to answer. Maybe we can get that from this chat manager, right?
We do actually have one question, which I can read out to you. Do you mean that for the logs, Q&A, and wiki documents, the accuracy is comparatively better when using a vector database such as Quadrant?
So so if you just have a semantic match, right, that you are trying to find an accurate information answer to a specific question, like suppose who is the president of India, or which particular city Eiffel Tower is, right? There's a close-ended questions when you're trying to get answer from those. Any vector database would help because they will be a little bit faster. They don't have to store the information the way it's supposed to be, and it does not require to do multi-hopping and give you additional insights. But as soon as you move away a little bit from that question answers ecosystem and want to have little bit more insights and also add little bit complexity to that particular question, then you'll be having some trouble with vector databases because they are pretty good with semantic match. I mean, no matter how you write in English, that's how they're good at. Like if I ask that, okay, what is the capital of India and is Delhi a capital of India? Question which have similarity and then answer with those particular similarity. That's what they are good at. But as soon as you move a little bit more complicated stuff and also wants a little bit of capability where they can, give additional information and additional insight with your answer, that's where I think you can draw the line that rather than using just a vector database, we can also leverage the possible the actually leverage the benefit of graph or and other traversal available to you. Planning to Okay, so I think that I get another question. Anytime soon you're planning to put all of these in agentic architect, like you have more than one mode of retrieval, right? Also, does agentic approach help you? So we are exploring certain ways to do this. Given the solution is still in development and we are still you know trying to get the accuracy to a specific level. Our majority of work goes into converting their messy data into a formats which we can store and which we can actually query upon. And yeah, I mean, we can go with an agentic approach in certain scenarios, specifically when we talk about finance department, where they have much more, complex query plan done within the data. But I think their customer support and then project management team would not require that much of a complex query plan. So we have thought about it, but we have not done any research on that yet. I hope that answered your question. I think we don't have any more questions. So that was my time. Thanks a lot, everyone. Have a good day with the other sessions.